Hello guys, welcome back. Today in this video we'll learn about the subject of optical wire and communication. In this subject we'll learn about the topic of multiple access techniques. In this video we'll explore different types of multiple access techniques and their applications and how they shape our digital world. Now let's come to the introduction of this video. Introduction to multiple access techniques. Sharing a communication channel. Multiple access techniques allow multiple users to share a common communication channel simultaneously. And we have efficient utilization. They enable efficient use of limited communication resources, maximizing bandwidth and minimizing interference. Now let's come to the first type of the multiple access techniques, that is TDMA. The abbreviation of TDMA stands for Time Division Multiple Access. As the name says, it mainly depends on the time division. The first time slots. Users are allocated specific time slots within a shared channel. Example in TDMA, if the users want to share a communication between each other in a specific channel, for that users a specific time slots will be allotted. Like this users should be communicate within these time slots. This way of communication is nothing but TDMA. And we have a sequential access. Users take turns transmitting data in their allotted time slots. As I said before, in TDMA, there is a sequential access, like time slots will be given continuously where users can take a turns which and where to connect, which and where the communication should be done. Example like GSM cellular network utilize TDMA for voice call for transmitting the signal. As we know, GSM cellular networks where we use a day-to-day life like calling each other, where we use TDMA. Now let's come to the second type of the multiple access techniques, that is FDMA, where FDMA stands for Frequency Division Multiple Access. Frequency bands. Users are assigned unique bands within a broader spectrum. As in a TDMA, users are allocated a specific time slots to communicate. Whereas in FDMA, users are assigned unique frequency bands within a broader spectrum. If the users wants to communicate in this FDMA, the specific frequency bands are allocated to each specific users where they have to communicate. Within that frequency bands itself, the users want to communicate. That is called FDMA. Simultaneous transmission. User transmits simultaneously without interfering with each other. Like as in FDMA, each users are assigned a unique specific frequency bands, so they have to communicate within each other within that frequency bands itself. So they are not crossing that frequency bands and communicating with each other. We have these advantages like user transmits simultaneously without interfering with each other. Example, analog cellular network and early cable television systems. Like for the example of FDMA are like analog cellular networks where we was using landline phones for the communication. Now let's see the third type of the multiple access techniques, that is CDMA. CDMA stands for Code Division Multiple Access. Unique codes. Each user is assigned a unique code to spread their signal across the entire frequency spectrum. And we have simultaneous transmission. Users transmit simultaneously without interference due to their distinct codes. As we seen earlier in TDMA, each users have been allocated a specific time slots. As we've seen in FDMA, each user has been allocated a unique frequency band for the communication, whereas in the CDMA, Each users have been allocated a unique code to spread their signal across the entire frequency spectrum. We have users transmit simultaneously without interfering due to their distinct codes. As we have unique codes, like where I have a code and another user don't have the same code. So this makes the advantage for the CDMA, like due to the distinct codes or unique codes between two users, there will be no interference between the communication. Example, CDMA is widely used in modern cellular networks like CDMA 2000 and DVDO. Now let's see the comparison of the TDMA, FDMA and CDMA. As we seen in TDMA, frequency allocation and time allocation code assignment. In these three ways, we'll see the comparison between them. In the first TDMA, frequency allocation is shared, time allocation is divided, code assignment not used. FDMA, as I said before, frequency allocation, frequency is divided in a frequency division multiple access, where the time is shared, code assignment is not at all used. As we see in CDMA, it is mainly concentrated on the code division, hence frequency is shared, time allocation is shared, code assignment is divided. Now let's come to the application of multiple access techniques. The first application is cellular networks. TDMA, FDMA and CDMA are essential for enabling mobile phone communication. The mainly multiple access techniques are used for mobile phone communications and wireless LANs. Wi-Fi networks use multiple access techniques for connecting devices. Multiple access techniques is also used in a wireless LANs, where Wi-Fi networks use multiple access techniques for connecting devices. If Wi-Fi networks has to be connected, these multiple access techniques should be present. And in the satellite communication, multiple access techniques is used. Like satellite networks utilize these techniques to spread their broadband internet access. In satellite communication, for connecting between each other like from the user to the side channel side, the satellite communication uses multiple access techniques. Now let's see emerging trends and future developments. The first one is 5G and beyond. Next generation wireless networks leverage advanced multiple access techniques for higher speeds and capacity. And the second is Internet of Things, the present future, where the present trends are on mainly concentrated in the IoT. Multiple access techniques are crucial for enabling communication between billions of connected devices. The third one is satellite internet. New satellite constellations utilize multiple access techniques to provide global broadband connectivity. Now let's come to the end of this video. We have seen multiple access techniques have revolutionized communication, enabling seamless connection across the globe as technology evolves. These techniques will continue to play a vital role in shaping our digital future. Thank you.